Hey folks, so you're going to see a video here shortly on a nice feature of this inverter charger behind me here where you can uh, set it up to prioritize use of the batteries over grid power, even though it has grid power uh, attached to it and supplied to it, or or generator power for that matter if you're running a generator. But you're going to see a series of videos where I'm showing the control panels I have upstairs for this inverter charger and the battery monitor. And it's just going to, so it shows some readouts, and it's going to go through a day or so or a couple days of cycling this thing through battery use, and then allowing it the grid to power it, grid power to go through the inverter charger while it charges the batteries, to kind of trickle charges it with the charger in here, and then letting the solar do most of the work. So it's a nice feature, and it's another reason I bought this inverter charger. And I looked at a lot of other inverter chargers, transistor based ones, and also ones like this that are transformer based. And I didn't find a lot of them that had this kind of feature. I can't recall if the Outback or Magnesign inverters have that feature. I would assume they do, since they're on the upper end of the quality / price scale. But a lot of the less expensive ones and transistor based inverter chargers don't really have this feature from reading all the instruction manuals, and another reason why I bought this one. Another reason to, if you're going to spend this amount of money on an inverter charger, or going to buy a quality one, make sure you read through the manuals. They're obviously free to read through online, and make sure it has the features that you want. So anyway, here you go. So what I'm doing is, instead of coming in here every day, or actually every few hours, and checking on the battery capacity amp hour meter here, so I've got it. It's a 300 amp hour nominal battery bank. Normally it gets pretty weak around 270, 280 amp hours, so that's why it says that. So it's getting down pretty close now. It's about 9:30 at night here. I'm ready to call it a day. And so overnight, pulling this amount of wattage, averaging between 300 and 400 watts, it's going to draw down to that cutoff level. And so right now I've got it at, let's see, the battery, well, I don't need to do that. Just go here to charge controllers screen. So the battery voltage is at 25.6. I've got this inverter charger set up to throw a low voltage alarm at 23 volts. These are lithium iron phosphate batteries. So at 23 volts, it's about 2.8 and some odd change volts per cell. Normally you only want to go down to 2.5 or so. So I'm setting a little bit higher than that to save a little more battery capacity, or make them last longer. So when this voltage gets down to 23 volts or below for, I think, 30 seconds or something like that, you can set the voltage and also the time that it spends below that voltage before this inverter charger will start drawing from grid power, or from an inverter, or from a generator if you have a generator running. So it's probably going to do that overnight. So we're sitting at 2:30. I'm going to use my handy dandy Victron app here. It'll focus. Sorry about that. So I only have one thing on here, the smart meter battery monitor. So that's going to connect here. And what I can do here is, so you can see some of the stats on there. It's pulling 16 amps, 412 watts from the batteries, whereas the inverter is only showing 338. So there's your efficiency loss through the inverter. It's not extremely efficient at these lower power levels. It's only pulling from the batteries about 1/10 of what it can do. So let's see here. So what I can do is go up here to history,
and it'll show me the last discharge, or the last discharge and the deepest discharge levels. So we got pretty close last night. When I came up this morning, it just barely got, the sun just came up just in time to charge me back up before it got down to the low voltage alarm. But it won't make it tonight. So we're going to see how that goes, and I'm just going to, so what I'm going to do is, I've got this inverter charger set to run grid power and charge the batteries back up, but what I'm doing is I'm only going to have this inverter charger charge at the lowest amp rating I can. So I've got it set at, if I go through the menus here, I've got it set to charge at 2 amps. And actually, with this battery monitor, it only measures less than 1 amp going into the batteries when it's at this level. And so that's the lowest I can set it at, because when I go to the absorption cutoff amperage, it'll cut it off when it gets below 1 amp, according to this guy right here. So we're going to see what happens in the morning. Let's see, if I go to the amps here, it'll just be throwing about less than 1 amp into the batteries, and the rest of the power, the rest of this 300 to 400 watts that's powering in our house right now, will be coming from the grid, and it'll just be trickle charging the batteries basically. And then when the sun comes up, the solar charge controller will do most of the heavy lifting to charge the batteries back up. Now it'll probably take a couple days, because batteries are a 300 amp hour bank, and so right now I'm only getting about, today I got 5.9 kilowatt hours of solar production. It's early March, so it'll get a lot better here later in the year. But so it's only going to do, it's about 40 amp hours per kilowatt hour. So it's 4 times 6. Let's see, 240. Yeah, I don't know. It won't get up all the way on the battery bank, but it'll get pretty close to getting pretty high charge, and then the next day we'll get it back up the rest of the way. But the whole time it'll be charging back up on solar and barely on the inverter charger. Then grid power will be running our loads. So I don't know, just gonna do a test here and see how it goes. So I can maybe do less work on my end on, having to go downstairs and turn things off and all the time, every few hours, and checking this quite often. We'll see how it goes, so I can do a little bit less work here and just let the system do what it's designed to do. So we'll see how it goes, and that's all for now. Stay tuned. So I forgot to mention that I want to show you, I showed you the charging current that this inverter charger is set at. That's the lowest I can set it at, because I have to set this absorption exit amps at 1 amp. So that's the lowest I can go. And then I also wanted to show you that, make sure we have grid power before we actually keep going forward with this experiment. So output 60 hertz, 120 volts. Let's see here, generator voltage is 0 because there's no generator running. Grid power 125 volts, good. So that's good to see. So there's grid power being applied to the inverter charger. It's just not using it right now because this green light is solid. I mean, it's inverting. And battery temp, let's see, that's the exterior battery amps. That's if you watch my previous video, this is the amps that are coming from the external charger, which we don't have hooked up. External charger terminals. The battery has 17.8 amps being pulled from right now. Battery voltage 25.4. This guy says 25.5, pretty close. And yeah, there's the power pulling. So we'll see how this goes in the morning. Okay, it's just after 5 o'clock in the morning the next day. This is what I woke up to. So the inverter charger showing it, sorry, its focus is terrible. It's on grid power, and the light here is blinking, which means it's in the grid power / battery charging mode. And the Victron battery meter shows this. I'm not sure why it just defaults to this screen. This is the difference in voltage between a couple of the 12-volt battle-born batteries down there. So I'm just gonna cycle through the menu here. There's the battery voltage, and yeah, there's the amps. It's putting the battery just below 1 amp, even though this one is going to say 2, thereabouts. Yeah, 2.1, 2.2. So anyway, must be some differences on the low end of the accuracy scale between these two meters. But anyway, 23 watts. And so we're at negative 276.4 amp hours. And this one's showing 24.9 volts on the battery. This one's showing 24, yeah, over 9. So we'll leave it there. And let's see what it's outputting. Yeah, 230 watts right now. That's via grid power. And it's taking in, yeah, 300 watts. So that's what we got here in the morning. So we'll let the solar do its job and see how far this gets charged back up tonight. And we'll take one quick look at the some more info on the battery meter. This is 25 volts. Okay. Yeah, just under 1 amp going in, 24 watts. And let's look at the history. So this only got down to 280 amp hours. It must have had a fridge start or something that kicked it down to a lower voltage temporarily. So it didn't quite get down to 288, which is the deepest it's gone. So, yep, that's what it got down to, negative 280. So right in the range of where I listed that it gets exhausted at. So, yeah, we'll see how this goes, and we'll update you tonight. All right, it's the evening now of the next day, so it's been about 24 hours since we've been doing this little experiment. We got about 5.5 kilowatt hours of solar today, and our battery capacity is now only down to 50 amp hours left to go until we're fully charged. We're still charged. Well, after the solar did its job, we're back charging the battery to about 1 amp from the inverter charger, which says it's been about 2 amps. But anyway, so that's where we're at. So we went from 280 amp hours down to 50. So we gained, what is that, 230 amp hours minus whatever the battery charger put in, which is 24 amp hours, I guess, over the course of the day. So yeah, about 210, 205 amp hours from solar. So at any rate, sometime late tomorrow morning, we should be, this thing should be going into absorb mode on the charging from solar, getting the voltage up so much, and then it should switch back from a charging mode right now to inverting mode with a solid green light. So we shall see what happens. All right, folks, I woke up this morning rather uneventfully. The inverter changed over to inverting mode, and you can see the battery monitor showing about negative 90 amp hours. Looks like it switched over to inverting mode again automatically around, I don't know, let's see, maybe 2.5 hours ago. It's about 6 a.m. now. It probably switched over around 3:30 or so, I'm guessing, based on the amp draw. So yeah, 6 a.m. there's no sun out yet, so it must have just gotten up to the 27 volts absorption mode setting, and it's drawn the batteries now again. I was hoping to catch it today, but maybe I'll do another video and catch it some other time. But yeah, so it worked. I'm just gonna leave it in this mode and let it cycle through the batteries as it wants to, and we'll see how it works. And at some point I'm going to get a meter on the incoming AC current or AC line to the inverter charger, so I can find out what exactly it's drawing when it's not in inverting mode. So anyway, yeah, sorry it was less than eventful, but anyway, it worked, and we'll see how it goes later on.
So it's been a few days now since I made that video, and I just wanted to mention I've left this inverter charger in that mode where it's prioritizing battery use, but then when the batteries exhaust, it will charge them back up with grid power, but it only uses the minimum amount of power that I can set it to, and then it uses the solar charge controllers using solar power to do the heavy lifting for charging the batteries back up. And so I left it running a couple of days, 3 days since then, and it's just it's cycled up and down a couple more times, and it's working perfectly like I wanted to. And so now I don't have to come down here and flip these switches all the time to manually manage the battery capacity. So I'm just going to leave it in this mode now for a while and see what it does. The only drawback is that there is the possibility where the power could go out right when the batteries are exhausted, and it switches to grid power to charge them back to run the power through the transfer switches in here. If that happens, well, I'd have to deal with it, but in my mind, that's a much less likely event than just the power going out. So in that event, two bad things would have to happen. The power would have to go out, and the batteries would have to be at the end of their cycle and depleted. So I don't see that as likely an event as the power going out. So anyway, hope you liked the video, and stay tuned for more.